In seismic waves, the three types are very important. Number one is the P waves, number two is the S wave, and number three is the surface wave. You can divide into two also, the surface wave and the body waves. Body wave में P wave और S wave शामिल है. Among these three waves, S wave are the most destructive one. So why? Because it move at right angle to the its own direction. So that's why it's very important for the uh, for discussion. Now, when an earthquake occurs, the seismic waves P and S waves speed up or spread out in all directions through the Earth interior. Seismic station will record seismic waves that have traveled through increasing depth in the Earth. As we have discussed that seismic waves travels more quickly through denser material and therefore travels more quickly with depth. Hot areas slow down seismic waves. Molten areas within the Earth slow down P waves and stop S wave because their shearing motion cannot be transmitted through a liquid. Partially molten areas may slow down the P waves and weaken S waves. When seismic waves pass between geological layers with contrasting velocities, reflections and refractions, and sometimes production of the new waves phases often results. Sometimes S wave produced from P waves. At arc distances of between about 105 and 140, no P waves are recorded. Furthermore, no S waves are recorded beyond about 105. Gothenburg in 1914 explained that this is a result of a molten core beginning at a depth of around 2900 km. Shear or S waves could not penetrate this molten layer and P waves would be severely slowed and refracted. Between 140 and 220 from an earthquake, another refraction is recognized by Lehman in 1936, resulting from a sudden increase in P waves velocities at a depth of 5,150 kilometers. This velocity increase in constant with a change from a molten outer core to a solid inner core. So S waves are detected up to 105 degree around the Earth surface. Now, if the earthquake is coming from this area, which is called the epicenter, the body waves, which are P and S wave, transmit from this center to all of the part of the Earth interior. So, when we have the change of the densities, abrupt change of the densities, this actually is the line which is drawn by the Gothenburg, and due to this change of densities, the S wave जो है वो इसमें से transmit नहीं होगी. Why? Because this is actually in a liquid form, and the most of the upper mantle and lower mantle are in solid form. तो लिक्विड में एस वेव ट्रांसमिट नहीं होंगी और इसलिए जो है ये तमाम एरिया जो कि 105 डिग्री ईस्ट से 240 डिग्री वेस्ट तक मौजूद है, ये एस वेव का शेडो जोन कहलाएगा. नो एस वेव्स आर रिकग्नाइज्ड हेयर, बट पी वेव जो हैं क्योंकि लिक्विड मटेरियल से थ्रू हो सकती हैं, इसको हम इस तरह से भी एक्सप्लेन कर सकते हैं कि इसको सिस्मिक रिफ्रैक्शन में ये चेंज हो जाएंगी और वो तमाम एरिया जो कि एस जोन का शेडो जोन है वहाँ पर पी वेव हमें मिलेंगी. लेकिन पी वेव जो हैं वो आम तौर पर उन एरियाज़ में जहाँ रिफ्रैक्शन हुई है वहाँ पर ये शेडो जोन बनाएंगी. सपोज़ ये 105 डिग्री से 140 डिग्री के दरमियान पी शेडो जोन बनेगा. इसी तरह से ये 220 से 240 के दरमियान जो है शेडो जोन बनेगा. Now here we have the P wave and S waves. So both are different because of their motion. Now first of all we discuss the what are the P waves. P wave actually when earthquake produce two types of seismic waves are produced also, and they are P and S waves. P waves are called the compressional or push or P waves consist of alternating pulses of stretching and compression through any material. They are also called primary waves. They are longitudinal in nature. P waves are pressure waves that travel faster than other waves through the earth to arrive at seismic stations first. These waves can travel through any type of material, including fluids, and can travel at nearly twice the speed of the S waves. Typically, speeds are 300 meter per second in air, 1450 meter per second in water, and about 5000 meter per second in granite type of rocks. So these are the P waves. But when we are discussing the S waves, they are actually secondary waves, are called also the shear waves or S waves. They are transverse in nature. In an earthquake event, S wave arrived at seismograph station after the faster moving P waves and displaced the ground perpendicular to the direction of the propagation. So the wave can take on different surface characteristics. The ground move alternately to one side and then to the other. S waves can travel only through solids, as liquid and gas do not support shear stresses. S waves are slower than the P waves and speed are typically around 60% of the P wave in any given material. The rock move up and down, so S waves are destructive in nature. So here we have the difference between the P and S waves. Why we are discussing more P and S waves? Because of their destructive modes. So P waves are compressional waves. So here we have most of the area which are under the compressional. So ये इसने material को यहाँ compress किया. So that's why we have destructive region there. But in S wave, mostly they are moving up and down. So material भी इसी तरह से move करता है और इसलिए ये क्योंकि P wave के बाद आती हैं, slow हैं, but इनकी जो mode of movement है उस वजह से destruction इनमें ज़्यादा होती है. So most of the जो destructive areas हैं वो इस वक्त fault lines के ऊपर मौजूद हैं और पाकिस्तान उनमें से one of the most important country where we have the fault lines. हम इस तरह से भी कह सकते हैं कि जो फॉल्ट लाइन के ऊपर इलाके मौजूद होते हैं वहाँ पर ह्यूमन सेटलमेंट्स कम होनी चाहिए ताकि डिस्ट्रक्शन कम हो.